Okay, everyone, welcome back. So now let's start from slide 13 to continue this chapter 1. So now let's look at some sampling technique. So before we talk about the sampling techniques, let's start with this example. So if we want to know the average height of all SHSU students, what we're going to do. So based on the previous video lecture, we know that we need to collect a sample from this population. So of course, we can treat every students at SHSU at as a population. Then we can select sample to obtain that or to estimate that information, because we really don't know the true population average, which is the average height of all SHS students. And we all know why already, because census is almost impossible. We have over 21,000 students at SHSU. So we are not able to find every student and ask their height. It's impossible. So now the question changed to collect a sample. How do we collect a sample, or what is a possible sample for this population? So based on the sample definition, any subset of the population can be considered as a sample. What about students from 3379 course? So that could be a possible sample. That could be a possible sample because it's a subset of this population, or 21,000 students at SHSU. So this will work. What about all females? Although we know female students still going to be about 10,000 students at SHSU, half of 21,000. So that's also a subset. So it could be a sample, but it's just not reasonable because still 10,000, that's a lot to survey. And what about this example? Someone said collect data from men's basketball team. Let's say 30 students, maybe. From this men's basketball team. It's still a subset, but in this case, 30 is a very, very small sample. Might yield some problem as well. So this is too large. And all students who have take 3379 before, so that's maybe a reasonable size of a sample. But 30, clearly that's too small, and not only small. And the other problem from this men's basketball team sample is if we want to use the sample to estimate, or to say the sample mean or sample average is very close to the population average, this is gonna be cause an issue, because students from men's basketball team, overall speaking, they're pretty tall, then use that to estimate the sample. Use that to estimate the population average will be overestimate probably. So that's why we need to discuss this sampling technique. So we're gonna collect some reasonable samples that we really want samples that are unbiased, not overestimate, not underestimate, just to be right. How to do that? We're gonna just find samples that from the population got an equally likely chance to be selected. So mainly, we're going to discuss 4 sampling techniques. We have simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So we're going to start with the very basic one, simple random sampling. So a simple random sample of size n is a sample chosen by a method in which each collection of n population items is equally likely to make up the sample, just as in a lottery. So now let's look at this exercise. For example, we want to randomly select 3 students from this class. And note that we have 25 students in this class. So how can we select 3 students randomly? Actually, we just need random numbers. So you may know the answer already. We need random numbers. We can just associate all 25 students with 25 numbers from 1 to 25. And now the question changed to select 3 random numbers from this 1 to 25 numerical value pool. So and also the question changed to how to get random numbers. So one suggestion could be this random number table. So it's very small, but if you you actually have these lecture notes ready, you can just click on this picture and then just make it larger to see what is a random number table. But for this 3379, we're going to introduce something that easier to obtain. This random number table actually from some computer software, generate random numbers, construct a table, just get it ready to use. Why not just use the computer directly? So we're gonna choose this technology, which is a random number generator. Actually, you can just Google random number generator. There will be a lot of options. So I actually tried a couple of those free random number generator online, and then I found this one is okay. So attach this link. You can click on this and then go to that browser to see what it looks like. So now let's go to the browser. So this is what it looks like. Now we can try this exercise. Random select 3 students. So that is select 3 numbers from 1 to 25. Let's see how it works. So the lower limit 1 to upper limit 25, and then we're going to generate. The first one is 13, and then the second one is 15, and then the third one is 6. It'll work this way, or we can choose this comprehensive version. So we type in 1 to 25, and then we're gonna have 3 numbers. They're all integers. Allow duplication in the results. We can select yes or no. So for this one, no, and then just integer generate. So it'll give you 3 random numbers from 1 to 25. And again, note that this random number generator is numerical value inclusive. So 1 to 25 means 1 and 25 also has the equal chance to be chosen. So 18, 17, 24, 3 numbers. Now let's go back to the lecture notes. Now we can just, of course, this process should be done first. Attach each number, each value with the student, and then now you know who gonna be randomly chosen by this process. Simple random sampling. And now let's look at the second one, systematic sampling technique. A systematic sample is a sample obtained by selecting every kth member of the population, where k is a counting number. So again, we're going to explain this systematic sampling using a access problem. So we're going to randomly select 4 students to receive 1 extra point towards the first midterm test. So this is not just an example. This is also a class activity. So now let's see who's going to be the lucky ones to receive this 1 point towards your first midterm. What we should do, so aside from this technique, we will see how to apply this technique later. But aside from it, we should first, if we want to select 4 students from 25 students, then we should first assign a number, a numerical value to each student. So I have this name list ready for this class. So now everybody got a number from 1 to 25. And now let's see how to use the systematic sampling to get the sample. Okay, so we then need the total number of students for the class, 25. So we have 25 students, and then the case number, k is more like a gap you want to pick. So is starting from a number, and then for every kth number, you're going to select until you got all 4 students. So if k is more like the gap, then we use 25 divided by 4. So we all know that 24 divided by 4, that's 6. So the answer actually is 6.25. So we'll just round it to 6, an integer, so that we got a reasonable gap. So now for this systematic sampling, we're going to randomly select a value from 1 to 6. So from 1 to k. So random select 1 value from 1 to 6 to be the first pick, or the initial number that we're going to start the systematic sampling method. So now let's go to this random number generator from 1 to 6, and then we just want 1. So this brief version should work. So now we hit generate. Number 3 is the random number we have. So the first pick gonna be number 3. And then we're gonna just automatically select every case. Then we can just get 4 numbers ready. So every case means if you select the third one, then the next one gonna be 3 plus 6, the 9s, and then plus 6, 15, and then plus 6, 21. And if you try use 21 plus 6, that's 27. It's already out of the boundary. So we want a number from 1 to 25 only. So it makes sense that we have successfully select only 4 students. So now let's see who's gonna be the lucky one. So 3, 9, 15, 21. 3, 9, 15, 21. So congratulations, all 4 of you. You're gonna receive 1 bonus point towards the first midterm. Okay, let's go back to these lecture notes. So next one gonna be stratified sampling. A stratified sample is a sample obtained by dividing the population into subgroups, or we call it strata, according to some characteristic relevant to the study. So know that there can be several subgroups. Then the subjects are selected at random from each subgroup. So now let's look at the exercise. So random select 2 students to be volunteers for later in-class practice problems. You will need to show your result on the whiteboard. So for this online format, we cannot really do that. So we'll just use this one as a example, not a real activity. So stratify. So the reasonable subgroup, if we want to select this way, could be gender, like we have in this picture. So the subgroups could be male students and female students. So I didn't count, but let's just say we have 10 male students and 15 female students in this class. Then select 2 students to be volunteer for a later class. Then actually we just need to select 1 student from each subgroup. So we have 10, so we random select 1 from the 10 male students using simple random sampling. And then select another 1 female students from this subgroup, so simple random sampling. Then these 2 students gonna be the sample. So this is how we use stratified sampling. Or we can just select student based on their major. For example, we have English major, math major, criminal justice major, or music major. So we can have several subgroups, and then for each one, you can obtain a sample of 1. So select 2 students if you have more subgroups. That's impossible because for this stratified sampling, you want to make it equally likely. So that's another example. Now let's see the cluster sampling. A cluster sample is obtained by dividing the population into sections or clusters, and then selecting 1 or more clusters at random and using all members in the clusters as the members of the sample. So it seems like similar to the stratified sample. But the difference is for stratified sample, when you have all the subgroups, you randomly select equal amount of subjects from each subgroup. But for cluster sampling, you randomly select the clusters, and then all subjects in the clusters will be included. So for example, again, we now treat the majors as clusters. So we have math, English, nursing, engineering, criminal justice. Let's say we just have these majors in this class. And then if we random pick students, we're gonna select, for example, random select nurse and then criminal justice. So all students that are nursing major or criminal justice major are gonna be included in the sample. That's cluster sampling. So a distinguish between stratified sampling and cluster sampling should be very important. Okay, now let's look at some other definitions. Statistic and parameter. So statistic is a number that describes a sample, and parameter is a number that describes a population. So we've been discussing about the population average, or we say population mean. So clearly, this is a number of or a value that describes a population. Then it is a parameter. And for statistics, what could be a statistic? For example, we collect sample from a population and then we calculate the sample average. or the sample mean, then that is considered as a statistic. Now let's look at the example problem. Which of the following is a statistic and which is a parameter? So for A, 50% of the teachers at Central High School are female. So we could treat all teachers at Central High School as the entire population. So when it is related to the population, we know this is a parameter. Now let's look at B. In a sample of 100 survey patients, so we know it's for the sample. So a number that describes a sample, a statistic. So we can just write down statistic for this one. Okay, so that ends the material for section 1.1. So let's just stop here, and then next video lecture for the same chapter will also be provided, and then that'll include section 1.2 and section 1.3.